Good day, everyone. I am Chantal Magdente, and for today's discussion, we will tackle and explore the Lucas numbers. So, what is Lucas numbers and where did it came from? We can say that, similar to the Fibonacci numbers, each Lucas numbers is defined to be the sum of the two immediate previous terms. However, in the Fibonacci numbers, the first two terms are 0 and 1, while in the Lucas numbers, first two terms are 2 and 1. So the Lucas numbers goes like this: 2, 1, 3, 4, 7, 11, 18, 29, and so on and so forth. Mathematically, Lucas numbers may be defined as this: Ln is equal to Ln minus the second term, which is 1, plus Ln minus the first term, which is 2, where n is greater than 1. So the pi or golden ratio between the two consecutive Lucas numbers emerges to 1.618033988875. Do you know that golden ratio can be seen in nature? Well, actually, it is everywhere. It is obtained by dividing a line into two parts, such that the longer part is divided by the shorter part, which is also equal to the whole length divided by the longer part. Again, remember that the golden ratio of the Lucas number is approximated as 1.61803 and denoted as pi. What can be the most interesting part is that this, where pi raised to n is the floor function, and ln is the nth Lucas number. But take note that this will not work for 1. So what does this mean? This means that the Lucas numbers can be derived from the golden ratio itself. So watch out for these examples as we will use the golden ratio.
Good day, I am Untitled Chapter. Today I will introduce to you 3 problems all about Lucas numbers. The first problem is, what is the 11th Lucas number? We have Lucas first term is equal to 1, Lucas second term is equal to 3, and so on. Lucas nth term is equal to Lucas nth term minus 2 plus Lucas nth term minus 1. However, instead of working back, we can find it by using the Lucas nth term relationship to 5. We know that Lucas nth term is equal to floor phi raised to n, for n is greater than or equal to 2, where phi is the golden ratio and floor x denotes the nearest integer function. So Lucas 11th term is equal to floor 1.61803 raised to 11. Then floor 199.005, and the answer is 199, which is the 11th Lucas number. Okay, for our second problem, what is the 8th term of Lucas sequence? But for this problem, we will use another formula, that is Binet's Fibonacci numbers formula for Lucas numbers. But in this formula, the equation is L sub n is equal to 1 plus square root of 5 over 2 overall raised to n plus 1 minus the square root of 5 over 2 overall raised to n. This formula is derived from the formula of Fibonacci numbers. So let's continue to find the 8th term of Lucas sequence. Just substitute the n with 18. So Lucas 8th term is equal to 1 plus the square root of 5 over 2 raised to 18 plus 1 minus square root of 5 all over 2 overall square root of 18. So we get 5,778, which is the 8th term. And for our last problem, what is the sum of the first 8th term of the Lucas sequence? So in this problem, we will find the summation of first 8th term of Lucas sequence. So we will use this formula or equation. S sub n is equal to L sub n plus 2 minus 3. Then just substitute the n with 18. So S sub 18 is equal to L sub 18 plus 2 minus 3. So the result is S sub 18 is equal to L sub 20 minus 3. But before that, we will find first the Lucas 28th term. Okay, to find the Lucas 20th term or the L sub 20, I will use the Binet's Fibonacci numbers formula for Lucas numbers. So L sub 20 is equal to 1 plus the square root of 5 over 2 all over raised to 20 plus 1 minus the square root of 5 over 2 overall raised to 20. So the result is 15,127. Let's go back to the equation. S sub 18 is equal to L sub 20 or Lucas 20 term minus 3. Just substitute the 15,127 minus 3. So the summation of the first 18 term of Lucas numbers is 15,124. Okay, that's all. That's the end of our discussion all about Lucas numbers. And thank you and God bless.